let's make a Pico-View prototype for January 2023. Every month, we will build a new prototype for Pico-View readers to learn, explore, and create your own spin-offs with. So while I'm showing you this month's prototype, take note of any ideas you might have for how you could add to it, polish it up, and put your own style on it. This month's prototype is called Near Miss, because the main mechanic of the game is to try to avoid objects while also daring to get close. Before we show you the code, let's go over the design sketch we made for the basic idea and gameplay. Much like Pong, there are two paddles on either side of the screen, but you control both paddles, and you are the ball. When you press a button, the ball flies straight across to the opposite paddle and stops. Every time you cross the screen, you earn a point. However, objects will be moving vertically, creating obstacles in the path of your ball. Collide with an object and it's game over. So it is a simple game of timing when to shoot the ball across the screen to avoid the obstacles. But there's a twist. You also gain a multiplier bonus every time you come close to colliding and still make it across, and that makes all the difference. Let's play the game first, then look at the code. Awesome! Now let's see how we built it. The very first line of code is setting a variable. High score equals 0. We are going to start by putting this before init because we want to keep track of a high score that does not reset every time we call init. Now let's put the rest of the variables inside init because we do want them to reset every time the game is replayed. The first two variables are for keeping track of scores. Score will count the times a player crosses the screen. Stars will count the times a player successfully near misses an enemy obstacle and is used as a multiplier when calculating the final score. Then we prepare a table to hold the player variables. X and Y is for the position of the ball. W and H, standing for width and height, is for the size of the ball. C is the color number, 10 being yellow. Speed is how fast the ball is currently moving, and died is the game over triggering variable, so its default is false. Then we prepare the enemy table and enemy related variables. We name a variable enemies and set it with the empty braces or curly brackets to create an empty table that we will fill later using a custom function specifically for creating more enemies. And since we will want to create enemies over and over again, it makes sense to put that in its own function. Offset is for how many pixels away from the enemy that we want to count as being a near-miss zone. In our prototype, you saw how we are actually drawing this near-miss zone, so let's change this variable to make the zone larger and see how that affects the game. Run the game. And now you can see the ovals around the objects are much larger, making the game easier. Alright, let's go back to the rest of the enemy variables. The next four variables are all tables, but they just hold a list of values. And in fact, we call this type of table a list. Spawn X is a list of possible horizontal positions that an enemy can spawn at. You can think of these as the columns that an obstacle will travel up or down. Spawn Y is a list of possible vertical positions an obstacle can spawn at, either above the screen at the top or below the screen at the bottom. Size is a list of possible heights and widths that an obstacle can have, and enemy speed is a list of possible number of pixels that the enemy will move every time update is run. We will use these lists when we create the enemy obstacles by choosing one of the options within each list, and we'll show you how we do that very shortly. Lastly, inside of init, we want to start each game with one enemy. So we call our soon-to-be custom function addEnemy. So let's look at that right now. We create our own function by writing function addEnemy. we first set two local variables that will only be used in this function: the Y position and the speed. Both of these depend on if the enemy starts at the top or bottom of the screen. So we need to figure that out first. We set a side variable by randomly selecting from our spawn Y list. You might already know that you can use this random function to pick a random number, but now we can also provide it with a table to get a random value from the table. So this works perfectly with our list of possible values. If you recall, spawn Y will either be top or bottom, and so each time we create a new enemy, that enemy will be randomly set to start at the top or the bottom of the screen. Then we check this side variable, and if it is top, then we set the Y position to -20 to be above the screen. We also set the speed to a random option within the enemy speed list. So let's say the first enemy we create is randomly selected to start at the top. Then this check is true and we set that enemy's Y position to -20. And then it will look at the enemy speed table and randomly select one of these values. So let's say the first enemy's speed is 1. The next time we create an enemy, all of this happens again. So let's say that top is randomly selected again, and so we set its Y position to -20 also, but this time the randomly selected speed is 1.5. And so this second enemy is much faster. And it's this easy to change what possible speeds you want your enemies to move at. You want them slower? Just add another value to this table, and it doesn't even matter where in the table you add it. Add as many possible speeds as you want in this list, and that is the only place in this code that you need to change in order to control all enemies' speeds. So if you only want one speed, then provide only one option in this list. Run the game now, and the enemy is very fast. So you can play with this to balance the difficulty in your game. Let's go back to our default and continue with the code. So we have an else here. That means if the side variable is not top, then we want to do this in any other case that side may be. But we know that if side isn't top, then it must be bottom. And we don't have to actually check specifically for that. So if it is not top, then we set Y to 138, which is below the bottom of the screen. And once again, we select a random speed, but this time we make it a negative number so that the enemy will move upwards. Okay, now we can prepare the actual enemy table and give it the variables it needs. We start by creating a local variable called enemy and open braces to make it a table. Then inside, just like the player table, we list out the enemy's variables we want to store in this table. Just like the player, the enemy will have an X, Y, width, height, color, and speed. The X will be a random value from this table. The Y we already set above. The width will be a random option from this size table, and the height will also pick a random number from this same table. So sometimes the width and height will randomly pick the same number, but more likely they will be different, allowing for skinny and tall or short and fat enemies. If you want to make this prototype your own game, but you want to use sprites instead of shapes, then you won't want to use these width and height variables. Instead, you could have one variable for an enemy sprite, but still use a table that is a list of sprite numbers that are your enemy sprites. And you randomly select one of those sprite numbers from the list. Easy as that. The enemy color could also be turned into a randomly selected color from a list, but we simply chose to set all enemies to the color number 12, which is blue. The speed we already set above, just like Y. And the last variable we want each enemy to hold is this one called flagged. We will use this to help us know if a player near misses an enemy, and we'll explain how it is used when we get to the collisions functions. That's all for this enemy table, so the closing brace closes the table. And finally, we add this local enemy table to our enemies table. It will have one enemy table inside of it and look something like this. Now let's get into updating the game. Function_update. We want to run the update until something triggers the game over scene. The player died variable is that trigger. So inside of update, we will check if the player died, and if that's true, then we will look for the player to press a button to restart the game. So if button press 4 or button press 5, which is X or Z on the keyboard, then we will first update the high score, but only if the player beat the old high score. So inside this check, we have another check. If the score multiplied by the stars is more than the current high score, then we set the high score to the new total of score times stars. So whether we update the high score or not, we want to reset the game variables and play again. This is as easy as calling init to run again, which will reset everything important back to their default values. Everything except the high score variable, because it is outside of init, and so it will still hold the high score. However, doing high scores this way will get reset every time you load and run the game. So it's not the best, but it is good enough to track your high score among back-to-back plays. Since we are already talking about the game over scene, let's jump down to the draw function and look at what the game over scene looks like in there. After clearing the screen, we do the same check we did in update. If the player died, then run this code. Print this symbol, which represents crossing the screen, X, meaning multiply, star, equals, total. We position it at 30x and 40y, and the color of 6, which is light gray. Then under that, we print an even odder string because we are building a string of text using a mix of number variables and strings. So let's break this line down. Get the score number. Then these double dots means switch between reading strings and variables. So switch and add a space, X, space, to the overall string. Then switch back to reading the number of the stars variable. Switch back again and add space, equals, and another space, and switch a final time to read the number of the total variable. And this is combined to be a single string to be nicely printed on the game over screen, showing the total score. After that, we check if the total is more than the high score. And if it is, then we print an announcement of high score underneath. If it's not a new high score, then we don't print that celebration text. We want the player to know that they can press Z or X buttons, so we simply print those two button symbols on the screen. And that's it for the game over screen. All right, now let's get into the actual gameplay and go back up to update. So this else means if the player has not died, then we play the game. We start with the button inputs by the player. You can see inside of here, we are checking if button 0, 1, 2, or 3 is pressed, which means left, right, up, and down. But we have all of this in its own if check, because before we allow the player to press a directional button, the player must not be moving. And we know the player is or isn't moving based on the player speed number. If it is 0, then the player is not moving. So we simply skip checking for any button inputs if the player is already moving. Now, if the player isn't moving, then we still want to limit which buttons can be pressed. For example, if the player ball is on the left side, then the player should not be able to press left to try to move more left. So after checking if button 0 is pressed, which is the left button, we use AND to make sure the player X is also more than 60 pixels on the screen, meaning the player must be on the right side. So if both of those are true, only then do we set the player speed to -4, which will send the player moving left on the screen, and we play sound effect number 3. That's this sound right here. We do a similar thing for each button. If right button is pressed and player X is on the left side, then set the speed to move right and play the sound effect. For moving up and down, we check if the up button is pressed and the player y is more than 8, which means the player is below the top edge of our screen, then we allow the y to decrease by 1 and move upwards. And the same for moving down and checking the bottom edge of the screen, letting the player move down. All right, next up, we update the enemies. Remember, we have the enemy variables in a table, and each enemy table is stored inside of the enemies table. Now there's an easy way to loop through the big enemies table and update each enemy. We use a for variable in all table loop. This will loop through all of the entries inside of the enemies table and create a local variable named whatever we call it here, and consider that entry as this local variable. So inside of this loop, it will take the first enemy and say, okay, this enemy is now called E. Now E is still this inner table, and it is still inside of the enemies table. But inside this loop now, we can treat each enemy as E. Just like we call the player table P and get player data like P.X for the player's X position, inside this loop, we can get the enemy data using E.X for the enemy's X position. See? But that is only true because we are using this awesome for E in all enemies loop. All right, so what do we want to update about each enemy inside this loop? Let's just skim the code for now to know what the loop will handle. It's going to check collision for the enemy, then check for near misses with the enemy, and if there was no collision and no near miss, then it's going to move the enemy, and then it's going to delete the enemy if it passes the screen. And that's in case the enemy completely crosses the screen. We don't want it to fly off into infinite space out of view. So it will get removed from the game after it's no longer on the screen. Then, after this loop checks and does those things for the first enemy, it will move on to the second enemy in the table, consider that one to be E now, and do all the same things again, but for the second enemy. Then loop again for the third, and so on. No matter how many enemies we add to the game, this code will handle updating all of them. So now let's dive into the loop and see exactly what it is doing. First, we check if this collide object function is true or false. We pass the player and enemy tables to this collision function, and it will return true or false. We'll look at the collision later. So for now, let's imagine the player and enemy do collide, and the code inside of here runs. So if collision is true, then we trigger game over by setting player died to true. We also want to trigger a sound effect depending on if the player reached a high score. So we check if score times stars is more than high score, then we play the happy sound of SFX number 2. That's this sound. And if the player did not beat the high score, then we play the sad sound of SFX number 1, this sound. And that's it for collision. But if collision is not true, then we want to check this enemy for a near miss collision. Let's say that returns true and the player successfully came close but did not collide with the enemy. In that case, we want to give the player a star, play SFX 0, this sound, delete this near missed enemy from the enemies table, and add another enemy to replace it. All right, now if there was no collision to end the game and there was no near miss to destroy this enemy, then we want to update the enemy's movement up or down the screen. To do that, we take the enemy Y and add the enemy's speed. After the enemy is moved, we want to check if the enemy has gone beyond our spawn zones. As we said, if we don't do anything about the enemies that cross the screen, they will stay in the game and continue to get updated over and over, flying away forever. That's pointless, so let's check if the Y is less than -25, too far above the screen, or more than 140, too far below the screen. And if either of those are true, then we delete this enemy from the enemies table and add a new enemy to replace it. And that is it for updating each of the enemies in that loop. Next up, updating the player. You'll notice this whole block of code is inside of this check, so it will only happen if player X plus player speed is less than 3, too far to the left, or more than 124, too far right. So basically, if the player, the ball, is about to move too far to the left or right of where we want it to stop, then we need to do this. First, we want to make sure the player is in the exact position we want it. In this prototype, we decided to draw our paddles more like tubes that shoot the ball back and forth. So the ball needs to stop in the perfect spot to look like it was caught by the tube. We aren't sure if the ball is on the left or the right side, so we need to check the player's X. And if that is less than 60, then we set the left position that looks good, which is 3. And if the player's X is not less than 60, then it must be on the right side of the screen. And so we want to stop it at the right paddle, which is 124 minus the player's width. If you change the shape of the paddles, then you'll want to adjust these numbers as well to find where on the screen you want to stop the player. Next, we want to stop the player from moving farther, so we set the player speed to 0. Since this means the player successfully crossed the screen and reached the opposite paddle, then we increase the score by 1 and play SFX number 4, this sound. The last thing we do when a player reaches a paddle is add another enemy into the game, but only sometimes. We want to control how often an enemy is added, so we check if a random number between 0 and whatever number is inside of these parentheses is less than 50, then add the enemy. The base number is 500 because chances of getting a number between 0 and 500 being less than 50 is 10%. And that means there is a 10% chance that an enemy will be added to the game every time you cross the screen, but only at first. Because as your score increases, we subtract your total score, score times stars, from the 500. And that will increase the chances of adding enemies. So the higher your score, the more likely another enemy will be added. But with this one line of code, we are balancing how difficult the entire game progresses. Alright, the very last thing we do in this update of the gameplay is moving the player. We take the player X and add the player speed just like we did to the enemies earlier. Next up, the draw function. We already looked at this part. Clear the screen, then check if the player died, and if so, draw the game over points instead of the game. But if the player died is false, then we draw the game. We use the same for-e in all enemies loop to draw each enemy. Each enemy is drawn here with 3 ovals. First one is the body of the enemy filled with enemy color. Second is an outline of the body to make it stand out. So it's just oval, not oval fill, and we set the color to 6. The third oval is just an outline, but we include the offset number to display the near miss zone around the enemy. Next, we draw the paddles, or what we actually turned into tubes. We draw a rectangle and an oval to make the tube shape, and position them based on the player's Y. Here's a helpful image to understand how we are drawing these. After the paddles, we draw the player. Now you may have noticed, and I'll play the game again to point it out. The yellow ball of the player looks different when it is sitting in the tube and when it is crossing the screen. The ball looks like it is a perfect circle when it is in the tube and not moving, but when it moves, it squishes like this to make it look like it is moving faster. So now let's see how we did that in this code. If the player speed is 0, then just draw the player oval using the variables in the player table. Since width and height are the same, the oval becomes a circle. But if the speed is not 0, we draw the player oval, but we squish it by subtracting and adding appropriately to the oval's corners. The last things we need to draw in the game are the scores at the top and bottom. So first we start with the top banner, which is just a dark blue filled rectangle. Top left corner at 0, 0, the top left of the screen. The bottom right corner at 127 all the way across the screen and 6 pixels down. On top of that banner, we will print this symbol and the current score next to it, not far from the left side, only 1 pixel down and in light gray color. Then we print the star symbol and the number of stars more to the right at the same height and in yellow. For the bottom banner, we draw another filled rectangle at 0 left side of the screen, 121 almost at the bottom of the screen, and 127 by 127, which is the bottom right corner of the screen. On top of that, we prepare the high score string, the word high score, followed by the number of the high score variable. And we print that string in the center of the banner using this bit of math here. Down near the bottom, and in color 13, a purplish gray. The only thing we haven't explained yet is how the collision works. We use two separate functions that are very similar. The first is the collide object function, and it takes two tables that will be locally referred to as A and B. And we will compare if A is inside of B. Let's look at where we are calling this function to run and see what we are passing as A and B. Remember that P is the player table and E is the enemy table. So the player will be considered A in the collision function and the enemy will be B. Keep that in mind. So now we compare each side of the player with the opposite side of the enemy like this. If the player X, left side, is less than or on the left side of the enemy's X plus width, which is the right side of the enemy. So to put that all together, if the left side of the player is to the left of the right side of the enemy, then we might be overlapping. So we check the next side. And if the player Y, the top side, is less than, above, the enemy's Y plus height, the enemy's bottom side, then we might be overlapping. So we check another side. And if the player's X plus width, that's the player's right side, is more than the enemy X, enemy's left side, then we might be overlapping. So we check the final side. And if the player's Y plus the height, which is the player's bottom side, is more than the enemy's Y, the enemy top side, then we are definitely overlapping. And in that case, we can return true. It did collide. And if we don't return anything, then it will be considered false. So we don't even have to write return false. That is our collision function. But how can we tell if we almost collide? That brings us to our final function in this prototype, near miss object. We are going to do the exact same type of checks for each side to see if the player is overlapping with the enemy. But we are going to add our offset number to each side of the enemy to check an area larger than the actual enemy's body. However, the player could enter this near miss zone and then on the following frame collide with the enemy, right? So we can't just consider entering the near miss zone as a near miss. That's why when we enter the zone, we will simply flag the enemy. This flagged variable attached to each enemy is like a marker to say, hey, we came close to this enemy. And the player might continue moving and actually hit that enemy and collide with it. Or they might continue through the near miss zone and safely make it to the other side. So if this enemy gets flagged, and on the next time that we check near misses with the enemy, then it might say that we're not colliding and we're not even near missing this enemy anymore. Well, that would mean that we did come close to this enemy and that we are safely on the other side of the enemy. And in that case, we can return true, saying yes, the player successfully near missed this enemy. And that's all you need to know about how this prototype works. play it as it is and share your high scores. But I also encourage you to take the code, take the cart, and make your own changes. Add to it, polish it up, give it a theme, add a background. Do whatever you want to do to create your own spin-off of this, while keeping the same mechanic of rewarding the player for nearly missing an obstacle. I can't wait to see what games are created from this, so share it on the BBS, tweet it with the hashtag Pico-View, and while you're working on it, join us on Discord to ask questions and share your progress. Enjoy the rest of Pico-View, and if you are not reading the Pico-View webzine already, then go to the link in the description and read all the great interviews and articles on Pico 8, and grab this game's cart to get started. Have fun!